Hi everyone, greetings from Fab Lab Bhutan. My name is Pema and I work as an edutech teacher here in Fab Lab Bhutan. So today we will basically take you through some of our milestones and the achievements that we had throughout this years. And our mission and vision remains to provide access, mainly free access to the tools, the platform, the knowledge and the global platform to the makers and the educators and everyone who's interested in digital fabrication. So we try to give them that platform for free as much as possible. And Fab Lab Bhutan was inaugurated in 2017, and these are some of the takeaways from our inauguration. It was graced by Professor Neil, then our former Prime Minister, and the former JICA Chief Advisor, Mr. Koji Yamada, and we also had the MIT team come to Bhutan to set up the lab, and also we also had Sherry from Fab Foundation and the team for the inauguration. So these are just some of the takeaways from the inauguration. And one of the greatest milestone and one of the greatest proudest moment for the Fab Lab Bhutan team is the development or the making of our own machines, the 4 core machines, which is the 3D printer, the laser cutter, PCB milling machine, and the CNC. And here are some of the boys and girls here explaining how they made these machines.
This one is for our Fab 2.0 project. As managers already mentioned, right now we are focusing on the Fab 2.0 project. So I'm doing on the CNC machines. So this is the overall model of these CNC machines, and we are just stuck by one component, and everything is ready right now. Everything just after that assembled, only after that component arrives, then everything will be ready. This is
what will be its like usage? Where are you going to use this?
It will be used for making the signboards, cuttings, signboards, and tables, furniture, things like it. Will be all done by the machine side, designing and all this automatic.
It can also build houses.
Build house, yes.
If you open any kind of electronic gadget, be it a TV remote or a calculator, inside there we will see one green processor. So that is known as a PCB. So we can print that kind of circuits here. So this machine will just print this kind of traces, and like pins and IC, we have to manually do it.
This is like where you can program it, where in your phone, computer, everywhere we have this circuit board. And this we can do it here in Fab Lab. We can program it here.
These are curved by this machine?
Yes, these are like copper plates. So he'll demonstrate one.
This can curve or print on any material?
Apart from like these circuit boards, it can even make to do like woodworking and acrylic working. So we can even do a wax molding. Like for the past 12 months, like I have been doing research on this and like designing, programming, everything. So then after that, like this is what I have come up with.
This is what he has made, replicated that machine here. So it functions are the same.
Except for the overall design, so it is just open and like it is just closed. So like all the materials we have used here is a locally available material, except for these motors and rod we have imported on. So like it's very hard to get these components. So like we have to order from China, US, Bangkok. Then it takes a lot of time. So there we took a lot of time.
Okay, please tell us about your creations here.
Hello everyone. It's also the one of the part of the like a major project we have been doing here right now. Like we are replicating the same machine out of this 3D printer. Like some of the all these printable parts, like this green one, orange, and all this gray color blue, we have been designing here ourselves, and we have printed in our printer only. Like only these metal parts we have exported from the other country. Like it will print same machine. It will work same as like these machines. Like our dimension will be same as this one. Like x-axis and x, y, z, and all it is same like this one. Like it can print like maximum size of like 200 mm in x, and like in y it's same like this it will print like a maximum of 200 size. Like for the just now we are still doing the process of this one. Like mechanical parts we have completed like almost like 90%, but for doing this one, like we have to, like for the calibration we have to do the right setting of this one. Like for being all of us for the first time, and we are having tough time to build like this one. But like mechanical parts, like we can build with the help of other friends. For the calibration, we are still under process, but like some layers we can print just now. Like we can show this. we have said in the G code, like this is called the extruder. Like this one is a heat bed. Like we have maintained in the G code, like first we have to heat this extruder till 200 degrees Celsius. Then only then it will heat this bed. Then only it will start printing. Right now, this it's in the process of heating extruder.
We are replicating this machine of 80 watt. So this machine is of 3-dimensional, mainly X, Y, and Z. So the laser light that is there is converted into the power that is generated is converted into laser light, and the laser light is reflected into the mirror. So it basically works with the principle of total internal reflection. So it hits the mirror down there and reflect to the mirror second, and it will finally reflect to the mirror 3, and finally it will be coming into the surface. So the working area of this laser cutter is of 3 by 2 feet, and the overall size of this machine is 150 centimeter by 90 centimeter. So as we know that Fab Lab's aim is to think it, make it, and share it. So we thought now we are making, and after making it, we are going to share it to a global network known as GitHub. It is an open source network where people can have access to it. So we are going to share it to that network. The function of this machine is same as the earlier machine, that is of 40 watt. It is just used for cutting, engraving, and making 3D reliefs. So we have used this timing belt and pulleys for moving X and Y, and sprockets and chain for moving Z axis. So this is how it works. So we just have a small controller that can move the axis.
So parallelly, we are also working on the Fab 17 for this year, and we have kept the theme as tradition meets technology. And this is the 3D printed mandala, which is going to be one of the main exhibition for the Fab 17, and it's going to be 5 feet 4 tall. And we have already done the color coding and everything that is necessary for the making of this mandala. So for the Fab 17, we are very excited for it, and we hope that we will be able to meet everyone here in Bhutan. And this is one of the most honored visit by His Majesty the King of Bhutan, and His Majesty wanted to see what Fab Lab is, how the impact of digital fabrication. So His Majesty visited our lab and experienced all those tools here. And one of the other greatest achievement of Fab Lab Bhutan is that is the extension or the networking of network of Fab Labs here in Bhutan. It was our humble contribution to the establishment of the 5 Fab Labs here in Bhutan. We have one is a Bio-Fab Lab, and we have a Fab Lab with CST in one of the college College of Science and Technology in the south, which will be funded by JICA. Then we have a Super Fab Lab here coming in the capital. We have a Fab Textile in the east, and we have a Fab Lab Paro also in one of the schools, Royal Academy schools in Paro. It's in the west. So these are some of the projects that Fab Lab Bhutan contributed to. And one of the some of the activities that we did were the National STEM Olympiad of Bhutan. It is more like the first global challenge. It's a robotics challenge, whereby it was a collaboration between the Royal Education Council and the Ministry of Education. The schools across Bhutan participated for it, and the winner was chosen to represent Bhutan in the first global challenge. And we are very proud to see that the students did very well, and they had the greatest exposure. And we also participated in the first global challenge, the first stands for inspiration and recognition of science and technology. It is more like an Olympic game, like whereby it happens every year in a different country. So 2018 we participated in Mexico, and 2019 in Dubai, and 2020 we couldn't do it due to COVID. So in 2021 it was a virtual competition, and we had more than 13 students compete for this first global challenge, and we're very proud to see that our students were able to come up with an amphibian robot which will be able to pick up waste from both the land as well as the water. And we also launched a very small prototype satellite to study the traffic in our capital city. So these are some of the takeaways from the first global challenge. And we every year for the last few years we have been having this pilot projects with the UNICEF Bhutan and the Ministry of Education, and the trainings we carried out to the youth centers, mainly the youth-friendly integrated centers, and we gave training them we gave training on the PyTalk, coding and programming. Then we also gave them training on the 3D printing, and we reached out to more than by this year I think it will be more than like 2,000 students, youths across Bhutan. So, and we also had a innovation challenge whereby the students will go out to the community, look at the problems that are being faced by the communities, local communities, then they will try to overcome those, try to solve those problems with the 3D printers and the digital fabrication tools. So the students did a wonderful job, and the UNICEF was very proud, and we are supposed to have a very big exhibition in the coming months. And these are some takeaways from the other outreach programs that we do here. We reach out to the youth centers, we reach out to the youths, the schools, and the organizations. We try to, mostly they come to Fab Lab Bhutan, they do a tour on the digital fabrication tool. They want to know what digital fabrication tool is. So these are some of the moments from there. The students trying to figure out what the tools are and how to use this platform. And these are advocacy on digital fabrication. With these are basically the officials from the ministries and the JICA. So they come here to understand what the impact of digital fabrication tool in this 21st century, and these are some of the takeaways. So as I've already stated earlier, we're working for the Fab 17, and we're very pleased that we have come a very long way, and in collaboration with the Fab Foundation, with support and from the national stakeholders as well as from the Fab Foundation. So now we have all the necessary documents that has to be legalized to host Fab 17, and we are very excited, at the same time very anxious. So this was some few takeaways from the Fab 14 when Bhutan was pitching as a host nation. So for the Fab 17, as of now, we have reached out to many speakers, and these are some of the speakers that has been confirmed. We have the Prime Minister from Bhutan, we have former Prime Minister of Bhutan, then we have the President of the College of Science and Technology from Bhutan, then the Chief Executive of Tech Park, and we have also reached out to the Honorable Health Minister of Bhutan. Then we have Sherry, we have Professor, and we also have reached out to Mahabirpan. Then we have Ma'am Kurma from the Director of Fab Lab Bhutan, and Thomas, the Director of Barcelona. And we have also reached out to the Danish Tech Ambassador and the Mayor of Wiley, and they've accepted our to come as the keynote speaker for the Fab 17, and we are reaching out to some few more, and we will be updating as soon as possible. So this is the financial model for Fab Lab Bhutan. We do it for 40-60. The model is 40-60, 40 whereby we try to generate some income to sustain our lab, and 60 we try to give out to give it out free as much as possible and make it as accessible as possible to the youth and the community at large. So this is our team. We have Madam Kurma, she's the director, and we have Mr. Tewang Lendo, who is also a technical and program manager, and this is me, and we have Sange, who is our fabricator, and he's also leading in one of the projects called Karma for All. So and we also have some other team members who come as pro bono, so we're very grateful for them as well. So this is all about Fab Lab Bhutan. We have so much to share, but we are very glad and grateful for the platform and for having us here. It's a great exposure for us, and hope to see you all here in 2022 in July. Thank you so much, everyone.